When making measurements on serial data signals, losses in the cables used in the test setup can reduce the signal amplitude and rise time, as well as introduce inter-symbol interference. These cable effects can dramatically alter your serial data measurements and potentially create mask test violations. A new cable de-embedding feature is now standard on all LeCroy SDA 7 series oscilloscopes. This new feature allows you to quickly specify the characteristics of the cables in your test setup and analyze your signal with the effects of the cables removed. Each of the 4 channel menus has its own cable de-embedding dialog so that you can individually describe the cable that is being used on each channel. The cable de-embedding feature allows you to specify your cable characteristics by entering either the attenuation table for the cable or the 2 attenuation constants of the loss model for the cable provided by the manufacturer. Then you must specify the delay and the physical length of the cable that you are using in your setup, and you're ready to view your corrected signal. Cable delay can be specified as either a propagation velocity, a nominal delay, or a dielectric constant, and the cable's length must be specified in inches. You can also save your cable configurations so that you can easily load them at another time. Here I have a PCI Express 2.5 gigatransfer per second compliance pattern, and I would like to remove the cable effects so that I can see a more accurate representation of the transmitted signal. I have created a copy of this signal in memory so that I can see the effect on the signal before and after cable de-embedding has been applied. I have previously saved a description file for the cable that I am currently using in my test setup, and I'm going to load this into the cable de-embedding dialog. Clicking Apply initiates the cable de-embedding feature for the signal on channel 1 so that the effects of the cable are removed. The compensated signal is a more accurate representation of what was actually transmitted. You can use the cable de-embedding feature in conjunction with all the other powerful tools that a LeCroy SDA 7 series oscilloscope has to offer, including measurement parameters and math functions. Here I have amplitude and rise time measurements before and after cable de-embedding has been applied. You can see with cable de-embedding activated, my transmitted signal actually has 25 millivolts higher amplitude and 10 picoseconds faster rise time than my non-de-embedded signal. You can also perform serial data analysis measurements on de-embedded signals where you can see how these cable effects were altering your eye diagram and jitter parameters. By unchecking and rechecking the cable de-embedding box in the channel menu, you can quickly see how the cable was affecting your measurement. LeCroy's new cable de-embedding feature is another example of why the LeCroy SDA 7 series oscilloscope is the world's most flexible and powerful tool for serial data analysis.